Okay, hello. We are Mose, and we will talk about Package Analyzer, which is a package that we developed, I think, 2 years ago to analyze the Julia open source ecosystem and do also something more. Maybe go to the next slide. Can you increase the font a little bit? Cool. So, as I said, we started 2 years ago working on this, and we actually gave a presentation, JuliaCon 2021. And the presentation, which is like presenting the package and the first results. So you can go back and watch this talk, and we also published the follow-up post on the on the Julia blog with the result that we presented at the JuliaCon. So there is a blog post where we present statistics like lines of number of lines of code in the general registry, documentation, testing, licenses used in the ecosystem, continuous integration, number of contributors. And as an example, there is here this distribution of the lines of code of Julia code in the Julia packages. And I think that's it. Back to you.
Cool. Oh, sorry, too loud. We recently introduced Package Analyzer version 3, which has some new features. One of which is now we can analyze non-trunk versions. So I'm going to make it a little bigger. Previously, we could only analyze the version of code that's living at the trunk branch of the repository. And now we can also analyze any provided version. So you can pass a version, and it'll analyze that version. And now defaults to analyzing the latest stable version, the latest released version, as opposed to the version at the development branch. But you can pass version equals :dev to analyze the latest code from the Git repository. One of the big reasons for this is that now it can understand manifest.tomls and accurately analyze the code no matter how that was added. So if it was pkg.add with a branch or a commit or a URL or pkg.dev or something else, it'll track down that code and analyze that particular version. Another new feature is that it can count lines of doc strings. So here is a very, very simple example, my test package. And you can see I've got this function greet, which is generated by pkg.generate, this package, but I added a doc string. And so we're going to see first why we wanted to implement this feature ourselves in Julia, which is that other standard tools do not tend to work correctly. So Tokay is a nice piece of software for counting lines of code. But in this particular example, you can see it doesn't have any comments. It actually counts everything as code or blank lines. So your doc strings here are counting as code. And this is what Package Analyzer used until this recent version. So we're not counting doc strings at all, and they're all counting as code. I looked at some other tools. SCC also seems to count doc strings as code, but it, for some reason, has one more blank line than the other ones. CLOC, this one works pretty well. It actually counts them as comment. It also has this extra blank line, but at least it's not counting them as code. But Package Analyzer counts the doc strings separately. So you can see we have this table with a column for doc strings. And in the source directory, we have 5 lines of doc strings. And with Package Analyzer, we can actually drill down and see how it is classifying each line of code. So this, again, is the source code that we had before. And you can see it's counting the module declaration as code. Then there's a blank line. Then there's 5 lines of doc strings, 1 line of code, another blank line, and then a comment. So one particular implementation choice here, which may not be optimal in all cases or any cases, is that if there's a comment on the same line as some code, we just always count that as a comment. We wanted to have one-to-one correspondence, like one line can only be categorized as one thing, so they add up correctly. And so we went with if there's a comment, then that outweighs there being code. So you have these precedence rules to look at each thing that we identify on a particular line and how to classify the line based on what shows up there. And this is powered by Julia syntax, which is really nice. So we don't actually have to do any parsing. We just traverse the syntax tree and see what is found there. Cool. So we use this package to analyze all of the general registry since 2020. So once a month, we would check out, well, we did this a couple weeks ago, but we check out the version of the general registry at some point in time. We look at the latest version of every package. We analyze all of them, and then we go 1 month later. And so with this, we have 40,000 versions analyzed of the packages, and we can look at lots of different things. So here's the number of registered packages over time. It's kind of linear growth since 2020. And right now, we're above 8,000 packages here. We can also look at the distribution of lines of code over time. So this is median over packages. That seemed to be the most representative. Pretty stable. Packages don't seem to really be getting bigger or smaller. About 400 lines of code is median. We can also look at lines of test code, which also is pretty flat. Lines of docs plus README and lines of doc strings. And the lines of doc strings are going up, so that's nice. People are maybe writing more doc strings. We can also look at percentage of packages with CI scripts over time. So here we look for the presence of particular CI scripts that we can identify, so we might be missing some. And that's pretty constant, almost 95%. We can also look at percentage of packages with OSI approved licenses over time. And in the blue line here is where we made a small intervention. We added a license check to registry CI. So Julia packages will not get automatically registered if they're lacking a machine detectable OSI approved license. And that we can see kind of did have an effect where the number of percentage of packages with license increased over time. And note also the overall number of packages is growing at the same time. So it's not just new packages, but the fraction. Okay. Percentage of subdir packages over time. So these are packages in subdirectories. This has been available since before this data starts, but it wasn't used very much for the first year or so, and it's climbed. But notice the y-axis here, it only goes up to 3%, so it's pretty rare still, but the feature has been used more and more over time. Okay, here I've got a demo. You can get this part of the Pluto notebook yourself by going to Eric P. Hanson /PackageAnalyzer JuliaCon 2023 to run this demo. But I'm going to zoom out a little bit. Will that work? Okay, so we can take a given package and a date and look at how this version of package stacks up against all of general on the latest release of that date. So the blue histogram here is all the packages in general, and the yellow line is our particular package. Here I put in Kairomaki. And you can see this Kairomaki has slightly more source code than average, if we look at the histogram. Maybe slightly less test code, slightly less doc strings, and slightly less docs and README, but all that kind of makes sense because it's a subdirectory package in the broader Maki package, which has a lot more of all of this. And we can change the date slider here and kind of see both how general has evolved over time and how some particular package has changed relative to general over the course of time. So I encourage folks to try out this demo with their own favorite packages to kind of explore this. But maybe if someone wants to suggest a package, you can put in another one and take a look at what we see. Is there any? Plots.jl. Okay, let's put it in. Can you hold this actually? Thank you. Cool. So maybe if we start at the beginning that we have data for, Plots was one of the largest packages relative to general, maybe middle of the pack in terms of test code. It's got a lot of releases we can see on the timeline, a lot of doc strings, not a lot of docs plus README. And we can kind of go forward in time and see how general has grown. The y-axis is absolute number of packages, so the histogram kind of grows over time. Plots has gotten more and more code over time and has stayed kind of one of the largest packages on this scale. Cool. Should we do one more? One more package? Yeah. Can you say it again? Chain rules. Cool. Cool. This is chain rules. We've got releases very frequently. If I can go back and kind of do the slider again. Okay. So back when general was small, chain rules was kind of in the middle in terms of lines of source, but a lot of tests, not tons of doc strings, fair amount of docs. Okay, now let's go forward in time. More and more tests. Look at that. Very cool. So now it ends as a very big package with a ton of tests, which is awesome. Cool. Okay, yeah, so I encourage folks to download this Pluto notebook. Also, all the data is checked into this repository, all the data from general, so that you can run this demo yourselves. Cool. Okay, let's go to the next step. One of the things that I'm interested in using Package Analyzer for is analyzing the dependency tree of some particular application to understand what are my dependencies. So we can use Package Analyzer's new version to analyze a manifest.toml. So this is a file that records the names, UIDs, and versions of all dependencies and transitive dependencies. And this provides a fixed set of versions for us to analyze, which is convenient. So we use this analyze manifest function call. Here, I put in a path to some fixed manifest, so it wasn't changing as I was developing this talk. You can optionally provide some GitHub authentication to download contributor data. And you can get out a data frame with lots of information about all of the packages. So this particular manifest has 231 dependencies, including some JLLs, and you have the repositories and things like that. Okay. So analyze manifest will analyze each package present in the manifest. As I mentioned before, even if the package is added by URL or branch or dev dependency, it should track down the right code. Also, one note is that by default, we catch exceptions and kind of suppress them so that if there's, when we're analyzing all of general, for example, it doesn't crash all the time due to things like incorrect syntax in old versions of packages and things like that. So this can be disabled by turning off the catch exceptions functionality, which could be important if you want to really understand everything that's going on in your particular manifest for your application. Okay, so we're going to ask 3 questions here. Does every transitive dependency in this manifest have a permissive license? Not just OSI approved, but I want a permissive license. Is any transitive dependency severely under-tested by some measure? And how does the test to source code ratio of these packages compare to general as a whole? Okay, so let's start with, does every transitive dependency have a permissive license? So here I'm kind of just demoing a workflow that you could use Package Analyzer for. There's not really helper functions for a lot of this built into Package Analyzer because I think it'll depend on exactly what you want to do with it. So this part we're just kind of showing what you could do with Package Analyzer. And this is also in that repo that I linked above. Okay, so we're going to check if each dependency has a permissive license. And we're going to start by only allowing MIT, BSD, and Apache licenses. And Package Analyzer uses this Go package called license check, which uses the SPDX identifiers, if you know what those are. So we're going to specify our licenses by these identifiers. So here I have this little function that's going to check the licenses that Package Analyzer found for each package. And it's going to assign them a green circle, a yellow circle, or a red circle. So the green circle means we think it's great in terms of these permissive licenses. Every file that we found that has licenses in it, we've identified at least 90% of that file. So generally that means there's not some unknown license that we couldn't identify that's also in that file. And every license that we found, these identified licenses, is part of this allowed set, MIT, BSD, or Apache. So when this case happens, we think, OK, that's probably fine. We'll give it the green check. In this case, we're not going to have this 90% rule. We're going to say, is there at least one file with one of these licenses somewhere? And if there's other stuff in that file too, that's fine. If there's other files with other licenses, that's fine. That's the yellow check. You might want to investigate to see exactly what the terms of the licensing is. And the red check is we couldn't find one of these 3 licenses anywhere in the repository, and maybe that's an issue. OK, so here I call my check licenses on every row of this table. And I can summarize it here. I found 223 packages with the green status, 6 with the red status, and 2 with the yellow status. So I might want to dig in and understand what's going on in some of these cases. So if I subset to the red status ones, Pluto kind of nicely displays these nested tables, which is cool. And so I can see my 6 packages here: free type, simple buffer stream, abstract Pluto, I don't know how to say that word, triplot base. Yeah. So we've got all these licenses, and you can kind of look through and say, OK, free type has the zlib license. That wasn't one of the 3 licenses that we put in at the beginning. Maybe we could make a call. Do we want to allow this to be one of our allowed licenses? Or do we want to not depend on free type anymore? Or what do we want to do? Simple buffer stream, at this particular version, we did not find any licenses at all. So maybe that's a little bit concerning. And we can kind of go through. And for simple buffer stream, one first check I did was, let's look at the development branch. So maybe the version that we have didn't have the license, but the repo has a license that was added later. So we can call analyze on simple buffer stream on the development branch. And this is the default printing we have for packages that we find. And we can see has licenses called the MIT license in the file named license. So great. It seems like the development branch indeed has an MIT license. And so maybe we can rest a little bit easier. Though maybe it'd also be great if simple buffer stream tagged a new release that included this license. We can also look at our yellow flagged ones and similarly kind of go through and decide, are we happy with what's going on? Are we not happy with what's going on? Maybe one interesting example is plot utils, where only 44% of the license file is like the lines of that license file are covered by licenses that license check could identify. So I guess there's other stuff in that file that license check could not identify. And so we could pull up that file and take a look and see exactly what the terms of use for this code is and decide if we're happy with it or not. OK, how are we doing on time? Do you know? Oh, cool. OK. We can also try to understand if any of our dependencies are severely under-tested. This might be concerning to us if we want to count on all of our dependencies working correctly. So in this example kind of analysis, we're going to look for packages that either have under 10 lines of tests, which seems like maybe that's too few, or packages whose ratio of lines of tests as a fraction of lines of tests plus lines of source is smaller than the 5th percentile of this quantity over all the packages in general with at least 10 lines of tests. And so these are actually, you can kind of drag these numbers, which is fun, a Pluto feature. And this is kind of enabled by analyzing all of general. So that's kind of nice. So we can go through and apply these rules to the non-JLL packages. We have 170 non-JLL packages here. And we can find it flags 9 of them as having low test coverage by one of these 2 metrics. And so we could subset to those and look into it more and kind of go through and decide if something's OK or not OK on a case-by-case basis. One thing I'll call out here is you can see there's this invalid project.toml. That means we could not parse the project.toml for this package. And to find out what package it is, because we don't have the name, we can pull up the repo and take a look. And we can see, for example, assigned distance fields only has the old require file. It doesn't have the project.toml because it's a very old package without releases. So kind of fun to find stuff like that in your dependency tree. And then the last thing we'll do here is how does the test source code ratio of these packages, my set of dependencies in this manifest, compare to that of general as a whole? And the green line is this manifest, and the blue line is general as a whole. And we can kind of see at each cutoff, this particular dependency has a higher proportion of lines of code that are tests to source than general as a whole. So maybe that's somewhat reassuring or not about this manifest. Okay, I can do it.
And the last things that we look at is the statistics related to contributors to the Julia ecosystem. So, for example, here there is a graph of how many contributors for each package, right? Yes. So you can see that on the median number of contributors per package is actually 2, which maybe can be a bit concerning or not, I don't know. So yeah, like vast majorities of packages are within 3 or 4, I guess, yeah, contributors. And then it's a long tail with a few packages which have between 46 and 216 contributors. And here we can see the number of contributors by package. So how many contributors, right? Yes, basically the kind of related to the previous one. But shown here like this plot. And again, we have some percentiles. Like no, sorry, how many? So here you can see where there are at least 2 contributors, where at least 10 contributors. So for example, 10% of packages around have at least 10 contributors, and 1.4 have at least 40 contributors. And then there is how many packages do contributors contribute to. So maybe first in linear scale. Okay, anyway, it's kind of the same. So, okay, so we found that there are about 7,382 contributors. By the way, for this we used the GitHub API. And so this only relates to packages which are hosted on GitHub. It's I don't remember the fraction of packages in GitHub. You remember? No.
No.
But it's the vast majority, but it's not the entire Julia ecosystem. And we also found that 2 years ago there were about, I think, almost 5,000 contributors. So this number of total contributors in the ecosystem grow by almost 50% over these 2 years. And so again, at least 7,000, around 7,000 people contributed at least one package. 3,500 contributed at least 2 packages, and this one is cut off maybe in the linear scale. So 39 people contributed to at least 100 packages. How many commits do contributors make? Again, there are about 7,000 contributors who made at least one commit. 5,840 people contributed at least 2 commits. 4,500 at least 5. Almost 3,000 contributed at least 25 commits. And then the last number that we have here, 83 people contributed at least 2,500 commits. And finally, probably we have how many packages do organizations have? So most of packages are hosted in the SciML organization on GitHub, and then there is Julia.io, Julia Smooth Optimizers, Julia Math. This I think it's actually a user, so we call them organization on GitHub, but this is actually a user account. Then there is Julia Pomdi, BioJulia, Invinia, Thomas Pub, and Julia AI. So this is the top 10 of the organization who host most packages, and I think that's it.
That's it. Yeah.
Okay. Yes. Thanks.
Thank you two very much. Does anyone have any questions? Oh.
How long did it take to run the analysis on all of General?
It took about like 20 hours. We had been doing it threaded before, and it was much faster. But then I think we ran into some hangs, maybe with OpenSSL and stuff. And so we switched to a serial version.
I think 20 hours to do the also the historical data, right? Yeah, I think a single run, when it was multi-threaded, a single run could take 10 minutes. Without multi-threading, it's taking longer. But yeah, so a single run, I think maybe 1 hour would be enough for a single run, like a single date. But for going back in time, it took 20 hours about.
Is there any way to change the hierarchy of the lines? Like, can I change when you do like inline code to the inline comments?
Oh, that's not customizable right now, but maybe it could be. Right now, it's just actually an enum, and so we just take the max of the categories we find on a line.
Who on earth is writing 2,500 commits?
Maybe you? I think we found 1% of contributors had that many commits, but some people might have very granular commits. Sorry, I can't hear your frames.
A few people at various points in time have run tools that have added a commit to like every single repository registered in general. So I suspect it's something like that.
No, so for some cases that I know of, I excluded those people. No, so I excluded when there is only one commit in the repository, because I know that those people contributed like automated pull requests. Mm-hmm.
Hey, quick question. So now that you're pulling in Julia syntax, could you potentially track the public API of packages and see how many are breaking semver over time, like what Rust is doing now with cargo semver checks?
Yeah, maybe. I do have a PR to like count exports and stuff like that, but I didn't get it finished in time for this talk.
This is also super cool. I was wondering for like JLL packages. So obviously I want to look at the license of the wrapper package, but for the artifacts themselves, the licenses generally don't live in the GitHub repo. They live in the artifacts. I'm wondering if that's something that PackageAnalyzer can do right now.
Sorry, I interrupt you because I think that here we are excluding GLLs, right? In all these analyses, I think that we exclude GLLs because they are like automated packages, and I don't think they're representative of like how people write code. So for that, for like distinguishing also the license of the artifact brought by the GLLs, I think we will need some more work on providing metadata for the GLLs, which at the moment we don't have. But yeah, so again, all these numbers that you've seen don't include GLLs.
I'd like to thank the both of you again for your talk, and hope you two are able to have time to enjoy the rest of the conference for yourselves.
Thank you.